Good evening, sir, and my dear friends. My name is Arunaja, and my roll number is 15. The topic assigned to me is the efficiency of the draft tube. Talking about the draft tube is a pipe of gradually increasing area which connects the outlet of the runner to the tail race. In a reaction turbine, the pressure at exit is less than the atmospheric pressure, due to which the water at the exit cannot be directly discharged to the tail race. And here comes the actual use of draft tube. The draft tube converts the kinetic energy at the inlet to pressure energy at the outlet. In draft tube, we supply water with kinetic energy, which is our input, and output is the actual conversion of the kinetic energy to the pressure energy. And also talking about the draft theory, which we has already learned. Applying Bernoulli's equation on the inlet and outlet of the draft tube and equating, we get the equation P1 by rho g equal to PA by rho g minus HS minus V1 square by 2g minus V2 square by 2g minus HF, where P1 is the pressure at the inlet, PA is the atmospheric pressure, HS the height from the inlet to the tail race, and V1 the velocity at the inlet, and again V2 the velocity at the outlet, and HF is the head loss energy between the inlet and the outlet. Now, coming back to our topic, efficiency of the draft tube. Efficiency of the draft tube is defined as the ratio between actual conversion of the kinetic energy, kinetic head to the pressure head in the draft tube to the kinetic head in the inlet of the draft tube. In draft tube theory, we has already learned that theoretical conversion of kinetic head into the pressure head in a draft tube is V1 square by 2g minus V2 square by 2g. And subtracting the energy head loss from the theoretical conversion, we get the actual conversion of the kinetic head into pressure head, which is V1 square by 2g minus V2 square by 2g minus HF. And the kinetic head at the inlet of draft tube is V1 square by 2g. Applying these two expressions in our equation of efficiency, we get the equation mathematically as V1 square by 2g minus V2 square by 2g minus HF by V1 square by 2g, where V1 is the velocity of the inlet, V2 is the velocity at outlet, and HF is the head energy loss in inlet and outlet. And thank you.